Video is being recorded as part of data mining course assignment taught by Professor Kiran Karmella at the University of South Florida. And in this video, I will be explaining a neural networks model using SAS Enterprise Miner. So first, I'll explain about my data. My data is occupancy data. Basically, it tells us if a room is occupied or not by the levels of CO2, light, humidity, and temperature. Occupied is my dependent variable. 1 means occupied and 0 means unoccupied. 1 means being occupied by a person and 0 means unoccupied by a person. So uh, my first concept is sample. So why do we take a sample? Because a data set may be too large for our software to handle, and also when the data is biased. So it may take an example, and I'll tell you why I'm taking a sample in this model. If you can see, I'm taking sample because my input data is completely biased, uh, because it has 6500 zeros, that is unoccupied stage, and by occupied stage I just have 1700 rows. So if we use this data, it is completely biased on zeros. If we use this data to train the model will be more inclined in predicting zeros than ones. So that is the reason I'm taking a sample, and to make the number equal, meaning both the occupied and occupied, both ones and zeros, I'm trying to make it equal, and I'm taking both as 1800. My second concept is data partition. This is how I've partitioned my data. I have partitioned it 40% to training, 30% to validation, 30% to test. So why do we partition the data? Because we partition it to build an effective model which has been trained, validated, and then tested to make it work for real-time scenarios. Here I've given 40% of training. We train this data to learn any patterns in the data, and then to make a model that makes new expected predictions. And then we use this validation data to understand the model behavior and to generalize on unseen data. We draw insights on how to tune the model using this validation data set. It is part of an iterative loop. We frequently draw insights from validation errors to tune our model, and then we divide it into test data to understand how the model would perform in a real world scenario. This is the data that the model has never seen, so it gives us a completely unbiased estimate of model performance. So this is why we partition the data. And now my third concept is the hidden layers in neural network. You can see it here. This is the number of hidden layers inside my neural network. We can increase and decrease this number. The hidden layers in neural network is where the black magic happens. Each layer is trying to learn different aspects about the data by minimizing an error cost function. The most intuitive way to understand these layers is with an example. In case of image recognition, such as face, we can say that the first layer may learn edge detection, the second may detect eyes, the third may detect a nose. In this scenario, we can assume like the first layer might detect the CO2 levels, the second the percentage of light, the third the humidity levels. This is not exactly what is happening inside, but the idea is to break the problem up into components uh, that different levels of abstraction can piece together, much like our own brains. Hence the name, the neural networks. So we can increase or decrease this. Increasing the number of hidden layers might improve the accuracy or might not. It really depends on the complexity of the problem. I've tried different. I've tried increasing and decreasing the number, and I found this to be optimal for my model. Now, my final concept is evaluating a model based on misclassification and confusion matrix. Now, let's see the results of my model. Uh, this is a model I've done using a sample with an unbiased data, meaning equal ones and zeros, because the previous data set was biased. So first, misclassification, it is 0.7%, and for test it is 0.8%. It is really good, and it is so too good to be true. So we cannot just see the misclassification rate. Generally, misclassification rate is the percent. It explains how many times my model is wrong. So the lower it is, the better the model. Now let us see the confusion matrix. This is my confusion matrix. So generally, the more true positives and true negatives, and the less false positives and false negatives, the better the model. As we can see, our model is pretty good. It is predicting all the true positives, more true negatives, and very less false negatives and false positives. You can see the percentage here, which is very high in predicting true positives and, and false negatives, and very less amount of false negatives and false positives. So so when a person is occupied, it is predicting he is occupied most of the time, and the same with unoccupancy, and very less type 1 and type 2 errors. So this means the model is pretty good, and that was my final concept, and thank you.